Hi, welcome to the third video on this series on data structures. In the first video, we looked at lists, and the second video, we talked about tuples. Yeah, tuples in in Python. And in this third video, our focus will be on sets. Yep, sets. So, what are sets? Sets are unordered collections of unique elements. They are mutable but do not support indexing. All right. The basic syntax of sets is similar to that of lists and tuples, but difference is the bracket. So here is curly braces. We use curly braces for set. We use braces, that is curved brackets, for tuples, and we use square brackets for lists. Now, how do we create and access elements in set? Since set doesn't support indexing, how do we then access or access the elements? Add elements, remove elements in set. Okay, so first let's see how to create and add elements in set. To create a set, all you need to do is just go ahead and assign a variable, that is, if you so wish. Pick a variable. Here I'm calling my set, the name of my set as my set, and the elements in my set are 1 to 4, 1 comma 2 comma 3 comma 4. So this is the same symbol or the same bracket that is being used to represent sets even in mathematics, right? So if you are representing sets in mathematics, you use curly braces. Okay, so how do we then let's run this separately so we can see the way Python we call the set. I'm going to paste this here and run this. So once I call my set, Python will give me the outputs of the list of the sets as presented here. If we intend to add the next element, an element after 4, say 5, to the set, we use the add method. All right, so let's see my set after adding. So now we have the elements 1, 2, 3, 4, 5 in the set we've just created. Sets automatically discard duplicate values. So when we use add method, the add method add elements to the set. So once if you have duplicate values in a set, the set will automatically take out the duplicate values. Let's see a practical example. So when we have a 2 here, comma 2, comma say 3, so I've added more elements to this set. When I run this set, I still have the output 1, 2, 3. Python will automatically discard this set because repetition is not allowed in sets here in Python. Neither is it allowed in mathematics, as under mathematics you don't allow repetitions of set of elements in a set in math. Okay, let's move on to see how to remove elements from sets. So since we've learned how to add elements by using the add method, to remove an element we use the remove method. Okay, simply say call the name of your set dot remove with the element you intend to remove from the set. So let's see the set after removing the elements. Now we have 1, 2, 3, 1, 2, 4, because we've taken out 3 from the set. Okay, let's go for that. Somebody might be asking, but we've added 5 to this set. Why don't we have 5 in the list? Okay, let's go ahead and run this cell again and then come over here and remove 3. Of course, there's no 3 to remove. It's going to give us return error. So now it's giving us error because it's saying, hey guy, we've taken out 3 already. No 3 to remove from the set. Now I'll run this set again, the first cell. So we have 1, 2, 4. Let's add 5 to the cell. We have 1, 2, 3, 4, 5. And now we can take out 3 from the set. And then we have 1, 2, 4, 5. Alright, so now we can see the 5 that had been added to the set. The reason why 5 didn't appear the other time was because I went back to run this other cell to alter the addition of 5 to the set. So this also explains that Jupyter Notebook actually executes the codes according to the order at which you run the cells. So if you intend to run cell 9 before cell 8 and then cell 10, please follow that order, because if you run 8, 9, 10, then the ordering of the positioning or ordering at which you run the cell will affect your output. Okay, having said that, I just left a very short note here to explain that remove deletes the specified element. It raises an error if the element is not found, just like we saw the error that is raised earlier. Let's look at let's perform some set operations. Like I mentioned earlier, we're going to see how to perform set, union, and intersection. Now we have two sets: set 1, which contains the elements 1, 2, 3, and set 2 has the elements 2, 4, 5. To perform set union, we use the pipe. This is called pipe, or a vertical straight line. The pipe symbol to perform union of two sets. So we have the union of two sets to be set 1 pipe set 2. Okay, that is one way to do that. The intersection of two sets is we perform using the ampersand. All right, so when we take the union of two sets, we have union and intersection. The union gives us 1, 2, 3, 4, 5, and the intersection is 3 because 3 is the common element in the two sets. So there is one syntax that comes to my head right now. I hope that the syntax will work. I just hope it's Python syntax and not any other programming software. There's a syntax that I remember. It's called, we have the dot union method. Let's see if that works here. Dot union. Okay, we have intersection, we have union. Great. So if I want to take the union, I can also say set 1 dot union set 2. Okay, when you do this, it gives you the union of the two sets. So it's either you use the pipe for union of two sets, or you say dot union. I can also say set 1 dot intersect intersection of set 2. Okay, this is also another way to take the intersection of two sets if you don't want to use the ampersand and the pipe. Okay, so those are two different ways of getting performing set union and set intersection of two sets. So if you are treating some mathematical concepts or sets under math, it means you can come over to Python and use it to perform your set operations. All right, having said that, I explained here that the pipe operator compute the union of two sets, while the ampersand operator computes the intersection of two sets. Let's now discuss set comprehensions. Just like we have set comprehension, we also have list comprehensions. We'll talk about those in a future video. What do you mean by set comprehension? Set comprehension creates a set based on an expression. Now, just like we have in math, we have set builder notation. That is a way of creating or defining sets. There are different ways of defining the set in mathematics. We define set by list, just like the way we've listed the elements right here. We also have set builder notation that allows us to define the elements of a set by a rule. That is exactly what set comprehension does in Python. We define the elements of a set using a rule. So here I say, let's set the set called the squared numbers be the set that contains all x squared for x in range 5. If I'm to write this mathematically, let me show you how that will be presented in a mathematical way. So this is going to be presented as the squared of, when you see this in mathematics, to translate it in Python, you translate just the way it's been presented. The square of numbers equal to, I'm going to use LaTeX to type other things, equal to all x squared such that x is in range 5. So x is in range 5 in math. I would write that to mean that x starts from, I think it's 1, right? X starts from 1 less than or equal to x less than or equal to that'll be 4, right? That'll be 4, less than or equal to 4. So this is the mathematical, okay, I didn't close my equation. So here's the mathematical representation of the set that has been defined below. Let's confirm if that's true. All right, so you can see that exactly. Okay, start from 0 actually. X start from 0, not 1. Start from 0 when you get the range of numbers. Now this mathematical representation of the squared of numbers, x squared from 0 to 4, is represented in Python this way. So in Python, I would say the squared of numbers equal to x squared. So squared is you perform squared operation in Python using the double asterisk, x double asterisk 2, which stands for x squared, for x in range 5. And that is exactly what had been written here. Just that I need to add one more condition here to state that, oh, the x's we're picking are actually maybe set of natural numbers or positive integers. Let's just say x is in integer, right? X is in integer. So this is how to write x is in integer in mathematics, right? So squared of numbers equal to x squared, such that 0 is less than or equal to x and x less than or equal to 4 for x is a member of integer. So it means that we are only interested in the whole numbers within this range and not the real numbers. I mean, the integers are not real numbers. And from Python, you would see that we have the output 0, 1. When you pick 1, which is an integer, 1 squared is 0. Pick 0, I mean to say, sorry about that. Pick 0, 0 is an integer, 0 squared is 0, you have it here. Pick 1, 1 is an integer within this range, 1 squared is 1. When you pick 2, 2 is an integer in this range, 2 squared is 4. When you pick 3, 3 is the next integer, 3 squared is 9. When you pick 4, 4 is the last integer, 4 squared is 16. And that's how to present it in mathematics. Mathematically, it's presented this way. And in Python, it is presented this way. That's called set comprehension, a very important very important way of representing or producing sets in Python. Okay, let's now discuss how to discard elements in set. There is a method called discard, right? I can just come here and say, okay, my set dot discard 2. I want to discard 2 from my set, and then let's see what we have left. We have 1, 2, 1, 4, and 5. The discard method removes an element if it exists, but does not raise an error if the element is not found. Okay, it doesn't raise error just like we saw in tuples. Okay, so there are many more methods of sets. You know, like I said in previous video, to see the methods of set, you can go ahead and call the name of any set dot, put a dot and press your tab key to give you a pop-up of the list of methods that can be applied to set. You can use the add method, the clear method, the copy method, the difference. This will help you take difference, that is relative difference of sets, the difference updates, the discard, the intersect, then intersection update, the is disjoint. This is asking, are the two sets disjoint? It gives you a boolean value as the output, true or false. Is subset, this is where you want to test if a set is a subset of another. Is superset, you want to check, is this set X a superset of Y? Then you can pop the elements from a set. You can remove. So pop and remove are two different things. When you pop, this is just showing the element, a particular element in a set. Remove it, take it out from the set. And this is symmetric difference when you're trying to get the symmetric difference of a set. And you can also perform symmetric difference updates, union, and update. So these are the various methods that can be performed on sets here in Python. Go ahead and check out how to work with all of these methods. Like I said earlier in a previous video, if you want to understand how to perform is disjoint, for instance, you don't know how to write the syntax. Once you type is disjoint, open your curve brackets, hold on shift key and press tab. With shift and tab key, it gives you the docstring, and this explains how that method works, right? So here it says return true if two sets have a null intersection. So it will return true if they have, if the intersection between both sets is actually the empty set, it gives you true. So that is all about the documentation, the docstring that you have for this particular method. Okay, so that brings us to the end of this video. Thank you very much for choosing Datafied Academy. Thank you for watching this video. Please, if you're yet to subscribe to our YouTube channel, I'll appeal that you should do so. That is one way to encourage us to keep pushing out rich and educating content around data analytics, data engineering, and data science. All right, do have a wonderful time. We'll see you again in the next video, where we'll be talking about dictionaries as a data structure in Python. Goodbye.